All right, let's take a look at nomenclature of esters and amides. And before we can get into the nomenclature, we have to be sure that we know what an ester is. And so the ester functional group is shown here. And we have to be sure that we know what an amide is. And the amide functional group is shown here. So replacing the hydrogen of a carboxylic acid with another alkyl group gives you an ester. So if you think about a carboxylic acid, right? A carboxylic acid is going to look like this. So if we replace this hydrogen with an R group, okay, like this, then you can see it's the same as what I have in the yellow circle. So that's what they're talking about when they talk about replacing the hydrogen of a carboxylic acid. All right. And when we're talking about an amide, the nitrogen analog of an ester is an amide. So if you replace the oxygen group here with a nitrogen, then you get an amide. Kind of a funny way of thinking about it. I would just more try to memorize what the functional group looks like. Okay, so an ester and an amide, but if you want to think about it in the way they're presenting it here, it's totally fine. And when it comes to naming esters and amides, we can use both common names and we can also use IUPAC systematic ways of naming esters and amides. So let's start with the nomenclature of an ester. And esters are named by a common system as well as by IUPAC rules. The common names are what we use most often, and it's helpful with both IUPAC and common names to think of esters as being formed from a carboxylic acid and an alcohol. So what they mean by that is, let's say you have an ester, okay? You have an ester that looks like this. Okay, and then you have your O R group here, and I'll just put a second R group. I'll put R prime just to say it's two different groups. Well, what they're trying to say is that this portion here, okay, this portion, you can think about it with the oxygen that has two single bonds on it. That comes from an alcohol. And then this portion here with the carbonyl, that comes from a carboxylic acid. So that's what they're talking about when they're saying think of it as being sort of a carboxylic acid and an alcohol being wed. Okay. So the first thing you're going to do is you're going to name the alcohol group. So if you have a methyl group, you say methyl, right? If this R, meaning if this R group was a methyl, it would be methyl, ethyl, propyl, phenyl, et cetera, et cetera. And then you're going to name the carboxylic acid part as a carboxylate. So let's say you had two carbons in the carboxylic acid portion, right? A two carbon carboxylic acid would be acetic acid, so it would be acetate. Or you could name it ethanoic acid, so it'd be ethanoate. Okay. And the best way to master is to practice it, right? If you practice it, you're going to get the hang of it. And so you're going to combine the alcohol group first, followed by the carboxylate into a final name. So if you take a look at the example that they've given you here, this portion here is the part that comes from the alcohol. And so you can see it's got a methyl group on it. So we would call this compound methyl something. And that something, well, if you have a two carbon carboxylic acid, right, if you think of this portion as coming from a carboxylic acid, you could either call this acid, let me use a different color pen here. If we had this acid, a two carbon carboxylic acid, that would be either acetic acid or ethanoic acid. So we could call this compound methyl acetate, or you could call it methyl ethanoate. Methyl ethanoate. Oh, wait. Okay, either one is fine. Now, most people would stick with methyl acetate because, like I said, common names are common for a reason. They're commonly used, but either one would be acceptable. So again, methyl acetate would be the common name. Methyl ethanoate would be the IUPAC name. Now, when it comes to naming amides, simple amides are named after their corresponding carboxylic acids using the following steps. Step one, we're going to name the carboxylic acid portion. And then we're going to change the ic ending or the oic ending to amide. So if we have benzoic acid, it would become benzamide. Okay, so if you remember benzoic acid, right? Benzoic acid is this acid here. So we have an aromatic ring, and then we have a carboxylic acid on it. So that would be benzoic acid. Benzoic acid. So if we change it to an amide, it would be benzamide. So let me just draw the quick structure of benzamide. There you go. So this would be benzamide. Anyhow, again, the more you practice it, the easier it will get. Anyhow, now sometimes you can have alkyl groups on your nitrogen. And now in benzamide, you have two hydrogens on your nitrogen. But what if you have an alkyl group on there? Well, that gets more interesting. The way you do it is you name the alkyl group, and it's going to be preceded by the capital letter N. So let's say you have a methyl group, you'd say N-methyl, or if you had two methyl groups, you'd call it NN dimethyl. Or if you had two alkyl groups that are different, you'd put them in alphabetical order. So let's say you had an ethyl group and a methyl group. E comes before M, so you'd say N-ethyl, N-methyl. Okay? And again, it might sound confusing just hearing it in a video, but if you practice it, looking at the practice problems in the textbook, they have the solutions to them, you're going to figure it out. So here's a couple of examples. So if we have a one carbon carboxylic acid, as is shown here, the common name would be formic acid. The IUPAC name would be methanoic acid. So if you change the OH group to an NH2, then it becomes an amide. So we change the ic acid to amide. So we get formamide. Or we change the oic acid to amide. So we get methanamide. If we have acetic acid and we replace the OH group with an NH2, we get acetamide or ethanamide. Now, going over that kind of example that I was talking about before, let's say you had your acetamide, okay, but instead of two hydrogens, so this molecule here is this molecule here. What if instead of two hydrogens, what if we had a methyl group on there? Okay, so let's say we had, I'll just draw the bonds here. So we have a hydrogen and a methyl group like this. Then you would call it N-methyl, N-methyl acetamide, okay? Or you could call it N-methyl ethanamide. I just don't feel like writing that down right now. So if you had two alkyl groups, okay? So let's say you had, and this is going to take more space, so let me just copy and paste this over here. So we copy and paste this down here. Okay, so let's say we had two methyl groups. Okay, so I'll replace this with another CH3 group. Then you would call it NN. So you have to put the N each time you have an alkyl group attached to this nitrogen. So NN dimethyl acetamide, NN dimethyl acetamide. And like I said, if this was an ethyl group, then it would be N-ethyl N-methyl acetamide, okay? And you could also call this compound NN-dimethyl ethanamide as well. But again, common names are commonly used for, they're common, okay? They're the ones that chemists tend to gravitate towards. However, all chemists, meaning you and me, we have to know both ways of naming. We have to know the IUPAC way, and we have to know the common way as well. Now, if you've done any studying in biology classes, or maybe you've taken a biochemistry class before, you might have heard the word peptide, okay? And even if you've never heard the word peptide before, I know you've all heard of amino acids. Now that the high protein diets are very popular, all the foods are high protein and high protein this and high protein that. Get your high protein ketchup and everything. That's a joke. But anyhow, so what is protein? Well, protein is just amino acids linked together. And when amino acids are linked together, they're actually linked together by amide bonds. But more specifically, when we have an amide bond between two or more amino acids or two amino acids, we call that a peptide bond. Okay, again, it's just an amide bond, but it's between two amino acids. So you can see here, this is an amino acid. This is the carboxyl group of an amino acid. We call that the C terminus. This is the N terminus of another amino acid. So if those come together and you lose water, and so the water would come from H2O, right? Two hydrogens and one oxygen over here. Then you end up forming a peptide bond. So this, again, this bond here is nothing more than an amide bond, but when it's between two amino acids, we call it a peptide bond. So if you look at the, primary, secondary, tertiary, or quaternary structures of proteins, well, the primary structure is actually the peptide bonds between individual amino acids. All right, let's see if we can give some common and IUPAC names for this ester and amide. So the first one, we want to name the alcohol portion first on this on this ester. So this is a phenyl group. So this is phenyl something. And you notice that we have a total of 1, 2, 3, 4 carbons here. So that would be butanoic acid. So it would be butanoate. So this compound would be phenyl butanoate. Okay. Now, I think the textbook says that that's the same name, or it's the same name whether it's IUPAC or common. I would argue with that. This would be the IUPAC way of naming this compound. The common way would be to call it phenylbutyrate. Okay, because the common name for a four-carbon carboxylic acid is butyric acid. So this would be the common way of naming it. Now, for the next compound, it's an amide, and you can see that it's got three carbons in the chain. So that means it's based off of propanoic acid. So we would go from propanoic acid to propanamide. So this compound would be called propanamide, and that would be IUPAC. However, the common name of a three-carbon carboxylic acid is propionic acid. So it would be the common way of naming this would be propionamide. Again, don't get frustrated with me. I'm just the messenger, but chemists, common names have just stuck around. I mean, IUPAC is agreed upon by the scientific community, but common names are, again, they're just used by chemists. We love them. We can't let go of them for some reason. So maybe someday in the future we'll ditch the common names, but for now, chemists love to use common names. And again, we have to know the IUPAC nomenclature as well.